Hello and welcome. This is question number 3 for the AQA AS Physics Unit 2 June 2015. Okay, so we've got this electric car. I've tried to draw it now. I think I've done a pretty good job of that. But as I say, you get the idea. Obviously it's online, but that's crucial for later on. We're going to be doing something with that during a few hours on that later on. Okay, but it says the vehicle accelerates from rest to 27.8 meters per second in a time of 4.6 seconds. The mass of the vehicle and the mass of the vehicle is 360 kilograms, and the mass of the rider is 82. So obviously, for the total mass, you just add them two together. But the first part of the question, 3A part 1, says calculate the average acceleration. Now, don't let the word average put you off. I mean, realistically, that's exactly what they should put, because that's what when we use Suvat equations, we're assuming an average acceleration. And that's because, obviously, well, part of the question is going to mention later on in the paper, okay, or in this particular question anyway. You're going to have to just realise that, obviously, as it gets faster, there's more air particles hitting it per second, a greater resistance, okay? So, therefore, the acceleration is not going to be the same when it sets off to when it gets to 27.8 meters per second. But anyway, what I always do, again, is note down everything we're given. Now, there's no point noting down the masses, okay, because obviously that's not going to be relevant for this equation. So, as I say, you know, it starts from rest. In other words, its initial speed is nothing, 0 meters per second. Its final speed, obviously, is 27.8 meters per second. Okay, and we know that the time it does that in is 4.6 seconds. Obviously, my amazing drawing there of some guy whose arms are actually bigger than his neck. Obviously, oh, well, that's stupid. Yeah, that's stupid. People with their arms bigger than their neck, stupid. But you get the idea. That's not really good. Anyway, so the time it does that in is 4.6 seconds, and we want to know the acceleration. Okay, so. What are the Suvat equations that we've got that we can help us that use u, v and t, and we can work out a? Well, obviously that's v equals u plus at. So therefore that's the equation we're going to use. Now v equals u plus at. Well, obviously we want acceleration, so you can just rearrange that to get a is equal to v take u over t. Okay, so therefore we know v is 27.8, and obviously u is nothing, so 27.8 take 0 over t, which obviously is 4.6 seconds. Okay, that gets us our acceleration, which you should find is 6 meters per second. I got 6.04, but for some reason they want it as 6. Okay? Right, so hopefully you can see why that is. Again, a very simple equation there. Now this next bit, I think they've tried to trip you up here, and I'm pretty sure I fell for this on the day of the exam. Okay, so it says calculate the average horizontal force which it accelerates. Now again, don't be put off by the word average. Well, there's worse things in this little part of the question than average. Okay, when it normally asks about average, you work out the force and then divide it by the distance. No, you don't, because we've not worked out the distance, so we worked out the average acceleration, so therefore it's going to give an average force. Because obviously what we're going to use here is F equals ma. Alright, well we've just worked out the acceleration, you're going to use that acceleration and obviously into F equals ma, but what's your mass? Now don't put, like I did, 350 kilograms, 360 sorry, because that's just the mass of the car. Now obviously there's going to be a person there. Unfortunately, people have to go in cars. I mean, you know, I'm sure cars will go out and do business by themselves, and humans will become extinct because they'll kill them off as they don't need them. Anyway, apart from the future of mankind, F equals ma. Right. So the total mass is obviously therefore 360 plus 82. So F equals combined 360 plus 82, and we're going to times that by whatever answer you got to part 1, which is obviously 6.04, etc., etc., meters per second. Okay. So therefore, that will give you your average force. Don't try and work out the distance and divide it by the distance, because that, remember, is your average acceleration. Okay. So sorry, because obviously I did this wrong, so I need to make it right. 4.6. Okay, so that gets you 2,671 newtons. Okay, so that's the answer for part 2. Right. Okay, so this next part, the question 3b, it's a long-winded one. Again, it's worth 3 marks though, so it's worth answering. It says, state and explain how the horizontal forward force on the vehicle has to change for constant acceleration to be maintained from rest to 27.8 meters per second. Now, for some, again, according to the examiner's report, because I actually had a look at it, I don't generally have a look at it, but I just wanted to know how people did, because obviously I did the exam, so I found it interesting, so hopefully, I mean, you'll just have to listen anyway. But essentially, what it was mentioning is the fact that people just, in this question, okay, because remember the horizontal force is the driving force, it's the forward force, okay, provided by just the engine force, think of it like that, and some people tried to, started the question correctly, okay, and I'll just point out, I'll just list like the bullet points of what you meant to write, because obviously I can't bother writing it all, because I wrote quite a lot. But people started to explain how an object could reach terminal velocity. So it is kind of, it's easy to go down that route, but just always, when you're writing this 3-mark answer, because I did write quite a bit, so maybe you didn't, maybe you wrote 1 or 2 sentences. I mean, you failed, but at least you won't go off track. Okay, so the first thing you should mention is for the forward force to continually increase, because remember, is that the horizontal forward force? Oh right, yeah, I'll show you. Sorry, 1 sec. Sorry, I would start reading out my answer if I tried to do that. This, remember, is the resultant force. So therefore, it's the result of the force. Right. Okay. So basically, what obviously you need to incorporate in this answer something about the resistance force is increasing. Okay, and to have an overall forward force, okay, resultant forward force, you need to continually, so this question is asking what happens to the driving force of the vehicle if you want to maintain constant acceleration, okay? So if you want to maintain constant acceleration, therefore, because acceleration is what determines the resultant force, in other words, because obviously mass is a constant, okay, you need to say that you need to make for constant acceleration to be maintained, you need to maintain an overall constant resultant force. Now, as you accelerate, okay, the resistance forces are going to be increasing. Generally, air resistance, okay, is the main one that you mentioned, and because air resistance is continually increasing, okay, you need to continually increase the forward force, okay, from the engine. Okay, now this weedy little electric motor probably couldn't do that unless it's a Tesla thing, but I doubt it. Considering AQA, it'll be a G-Whiz. Anyway, apart from the fact I'm going to present Top Gear next year, I'm going to fire Chris Evans, as I've already mentioned. Yeah, so we need to have a continually increasing forward force because there's a continually increasing there's a continually increasing resistance force. So we're assuming that the forward force initially was greater anyway. Well, it has to be, surely, because otherwise it would be going backwards and it'd screw up, basically. So what I'm trying to say, I think, is that because the air resistance is continually increasing, to keep that gap, because obviously the forward force will be greater, I think it's probably, so the forward force needs to be continually greater than the resistance forces. Okay, so if it needs to be continually greater than the resistance forces, the gap between the forward force and the resistance force, so if you took away the forward force, you go forward force minus the resistance forces, that value needs to be the same. It needs to be a constant, okay? Because if that's a constant, then the resultant force will be a constant, therefore there'll be a constant acceleration, okay? So for that to happen, there needs to be a constant difference between the forward force and the resistance forces. Now, as I've already said, the resistance forces increase as you go faster, because obviously there's more air particles hitting the vehicle per second. It has to push more of those air particles out of the way, okay? So therefore the resistance force will be increasing. But as I say, we need to maintain that constant gap. So therefore the forward force also needs to be increasing, but at the same rate. In other words, if we're measuring these in newtons, okay, if the resistance force increases by 5 newtons, then we're also going to need to increase the forward force of the engine by 5 newtons, okay, to maintain that gap, constant gap between the two. So there's a constant overall force, so therefore resultant force. So therefore as there's a constant resultant force, okay, then a resultant force equals mass times acceleration. So we presume mass to be a constant, so therefore that gives a constant acceleration. That's what you need to mention. You just need to mention really about the fact that resultant forces are increasing, okay? So that as you accelerate, as you go faster, okay? So therefore, to maintain a constant acceleration, because F equals ma, all right? And that we need a constant gap, if you want to put that into your own words, okay, between the forward force of the engine and the resistance force, okay? Therefore, we need to maintain the gap, so then we need to keep continually increasing the forward force as the resistance forces increase. And you need to mention, we're not going to increase it by too much, we're going to increase it by exactly the same amount that the resistance forces increase. Now obviously that's going to be very hard to measure, and you'll probably be like this the entire journey. Put your foot down and actually rotate your foot through the carpet of the car, okay, and then obviously you'll hit your head on the floor, people will die, but at least you'll be accelerating at a constant rate. Okay, so anyway, hopefully that is explanatory. Now, this is next bit of the question is really sneaky, because they look like, I mean, obviously you can look online, but just for the benefit of those people who couldn't be bothered looking online, because I'm that kind of guy. Is the camera focusing? Yeah. Obviously, that's how much I wrote for 3B, but essentially, just what I've mentioned about them 2 or 3 points. Now, this part here, 3C, actually, when I did this paper, I'm pretty sure I missed out and just went straight onto this and started answering this, 3D. Now, apart from the fact I can't see the alphabet goes from B to D, because obviously I'm probably genuinely in the exam, we're talking, basically this 3C that I probably missed out on the day of the exam, is talking about, we've got to add arrows to this diagram, okay? And it says electric motors drive both wheels of this vehicle. Add label force arrows to figure 3 to show the horizontal forces acting on the vehicle when it is moving at a constant speed. Now, apart from the fact I didn't see this question, there's a few other points that I want to make out. It wouldn't have mentioned the fact that the electric motors are driving both wheels if it didn't want you to specifically put arrows on the wheels. It would have just said the engine provides a forward force and there's a constant resistive force or whatever. Draw the arrows on the vehicle to show this. Now, the fact that it's mentioned that the force is being driven by both wheels is a key thing. I mean, even if it's only been driven by the front, you should just draw it on the front. Well, because it's talking about driving both wheels, you need to draw arrows from both wheels, from the axles of both wheels, or the centre really. If I drew it in the centre, you couldn't really see it, but you get the idea, and they would see it on the day of the exam, obviously. Okay, and now, so they're the forward forces, and it's asked for the horizontal forces. So obviously the other force is the resistance force. Now the fact that obviously there's going to be a constant acceleration in this, there needs to be a constant overall resultant force. So you could say, if you were being really anally specific, these two arrows need to be exactly the same length, okay, and they need to be bigger than the resultant, so the resistance force going backwards. Now, where would you put this resistance force? In the mark scheme, it doesn't say it has to be at a certain point, unlike these two. So it could just be from the rear of the vehicle, okay. So something like that. As long as you label this arrow resistance force is just air resistance, etc. Even though we know really that the resistance is not just in the form of air resistance, also on the form of the resistance between these tyres and the road and all the other bits of resistance you have inside the internals of the engine. Okay, you could just label that arrow as resistance. You don't need to be, you don't need to be an engineer to draw the arrows on there. Okay, so that's 3C, and hopefully you can see why that is. So really, it's just, it gives you a heads up really of where to draw the arrows and what to talk, what to mention really in the explanation to that 3C. But as I say, if you didn't spot it, it's only worth 2 marks, so it's not the end of the world. Okay, so apart from, it's the end of your life, but it's not the end of the world, so other people that have the worry as much as you do. Okay, so for 3D, again, this is a question which is fairly easy, but I think it's the wording that may have put some of you off. So if you got this question wrong as well, that's 4 marks gone straight away. Okay, so what does it say? Probably could read it out to you, probably better. The vehicle now accelerates at a constant speed. Constant speed. It accelerates to a constant speed, so therefore, when it gets this speed, there's no acceleration. The useful power output of the motors is 22 kilowatts. In other words, you obviously need to convert that into watts, which is 22,000 watts, obviously, at this speed. Calculate the horizontal resistive forces acting on this vehicle. Well, you may go, hang on a second. It's mentioned about the output of the motor. Okay, so let's just write down again what we've got. Okay, so we're told that it accelerates to a constant speed. Now, you don't obviously need to work out the acceleration up to that constant speed, because all we're considering, obviously, is the forces at this constant speed of 55 meters per second. Okay, and it says the useful power output, in other words, the power. You could put in brackets useful, but it doesn't matter. Now, obviously, normally when it mentions useful, it's something about efficiency, okay, but in this case, it's just, when you're talking about the useful power output, it's the power output provided to the wheels. In other words, it's the power going forwards, okay, so obviously that is 22,000 watts. Okay, calculate the horizontal resistive force acting on the wheels. So we need to calculate the force, but you could go, well, we could use the equation power equals force times velocity. But if we did that, this is the power provided to the wheels, and this is the velocity it's moving at. So surely this force here is the force that is provided by the engine, or the useful power force, or whatever we want to call it. Well, yes, that is true, but the fact it's not moving at all, it's not accelerating. Therefore, when it's not accelerating, there's no resultant force. In other words, the resistance force are equal to the forward force of the vehicle. Now, it's not asking to state that in your answer, okay? Not to state, that is why we could assume that force there that we would normally see if we were just working out this equation, okay? We would normally think that force was to do with the force provided by the electric motors to go forwards, okay? And you don't have to specify that is now the same because it's moving at constant velocity as the resistance forces. Although it's just a little thing saying force forwards equals force backwards. That's literally what I wrote, just to show the examiner that I know that this equation really would be to do with the force going forwards, but we can also calculate it as a force backwards. But maybe that's getting too complicated. All it simply is just subbing numbers into that formula. Okay, so again, it's 22,000 watts is equal to the force times the velocity. The velocity is 55 meters per second. Sound like an asshole, but I mind. So anyway, rearranging that equation gets the force is equal to 22,000 watts over 55 meters per second. Okay, so hopefully that makes sense. Okay, so when you would do that, okay, equation, obviously probably should have done that for you. The force is 400 newtons. Now if you didn't convert this, okay, you didn't convert it to the 22,000 watts. Now the reason why you need to do that is because obviously the power, the velocity is in meters per second. Well, actually, yeah, if you'd have left that as 22 kilowatts, okay, as long as you put your units, change your units, and didn't put the force just in newtons, okay, put it into whatever it was, kilowatts per meter per second, okay,
you should be fine. But I think it's just easier just to convert it to SI units, watts, okay, and then rearrange and simplify to 400 newtons, okay? Because it does ask you, it doesn't ask you to give units because it's already provided with units. It's already given units in the term of newtons, okay? So that's why you need to convert it, okay? Now, as I say, you don't need to convert it, but you'd have to probably change the units, and I'm not sure. The examiner probably wouldn't like that, okay? Someone changing his units. God's sake, that caused anarchy, that. Right, okay, so that's the end of question 3, worth quite a nice 11 marks, okay? So thanks for watching, hope it's been helpful, and we'll see you in the next video.